Greetings, ladies and gentlemen. In this video, I will go over the nth term test for divergence. And now, what this test states is that as limit approaches infinity of a sub n, and this is not equal to 0, the series would diverge. Okay, so limit n approaches infinity of a sub n does not equal 0, then the test tells you that your series a sub n diverges. Okay. Now, if you do take the limit as n approaches infinity and your answer comes out to be 0, then the test is inconclusive, or the test fails, or in other words, it doesn't tell you anything about the behavior. The key word for what this test is used for is right here. The only thing that this test will ever tell you about is if the series diverges. Now, the other thing is that this is one of the most basic tests ever, because this is the only condition for it. In other words, if you have any series, try to use this test on it. And if it doesn't work out, then you can use something else. But if it does work out, it can save you a lot of time. All right. Now let's jump straight into some examples. Let's see. If, for example, we have let's see, summation. Do it right here. N over 2n plus 3. Now, what is our a sub n term? Well, this is our a sub n term. Now, notice that I am not putting the limits, and the reason for that is because we're already assuming that this is an infinite series. Additionally, for these problems, it doesn't matter too much. So, we take the limit as n approaches infinity of our a sub n term, which ends up being n over 2n plus 3. Okay, this is our a sub n. Always. This will be equal to, let's substitute infinity on the top and the bottom for n. We'll get infinity over 2 times infinity plus 3. Now, let's simplify that. This comes out to be infinity divided by 2 times infinity. Well, let's think about this. Infinity is a really, really, really large number. So 2 times a really large number ends up being just a really large number. Now, a really large number plus a 3, well, that's still a large number. So in other words, this term down here simplifies down into infinity. Now, if you have any questions regarding how we did that, let us know, and we'll make a video just talking about how infinity works in these limit problems. Now, infinity over infinity is an indeterminate form, and we can use L'Hopital's rule for that. Again, if you have questions about what L'Hopital's rules are, let us know, because they're usually taught as a prerequisite for these problems. So, what this form states is that we take the first derivative of the top term and the first derivative of the denominator term and see if we can simplify our series. In other words, we will then get limit as n approaches infinity of, well, what is the derivative of n with respect to n? And it ends up being 1 divided by the derivative of this term right here. 3 goes to 0, 2n becomes that. Now, the limit as n approaches infinity of 1/2, that ends up being positive 1/2. Now, let's look at what this says. The limit as n approaches infinity of our series, if it does not equal 0, then our series is divergent. Well, in this case, 1/2 is not equal to 0. Therefore, we can conclude from this test that the series n over 2n plus 3 is a divergent series. Okay? Now, let's go over another example right here. I'll just write it right here. How about sigma 1 over n? Again, you can use a lot of tests. The first test that should always come to your mind is, can I use the nth term test for divergence? So let's try it. Limit as n approaches infinity of 1 over n is equal to, well, let's substitute the infinity in, 1 over infinity. Now, let's think about this. 1 over a really really, really, really large denominator. Now this denominator is so large that when you divide the 1 by it, you get a really small decimal value. And because of that decimal value, it's so small that we say that it approaches 0. In other words, we'll say that 1 over infinity, or any number usually over infinity, we tend to say that it approaches 0, or we approximate it to 0. Now, what does this tell us? This tells us that we took the limit as n approaches infinity of our a sub n, and we ended up getting 0. What does the test tell us if we do get a 0? Well, all that it says is that if it does not equal 0, then it diverges. If it does equal 0, on the other hand, the test fails, or it is inconclusive. All right? Now let's just go over one last example. I'll come on this side. Okay. Sigma 2 to the n. All right? Now, first step, this is our a sub n. Okay, so we do limit n approaches infinity of a sub n, so 2 to the n. All right, now let's substitute our infinity into there. We got 2 to the infinity. So in other words, we have 2 to an incredibly large power. So 2 to a really large power ends up just being a really large number. In other words, this just ends up being infinity as our answer. Now, is infinity equal to 0? No, infinity is not equal to 0. Therefore, this test holds true and the series diverges. Okay? Now, I just wanted to say one more thing about this test right here in particular, or about this example in particular. In this case, our test ends up equaling 0. So what do we do from there? Well, we go on to another test, or we try to identify what type of series that we are working with. All right? And in our future videos, we will go over some of the other tests and some of these specific types of series that we have.